Yeah, welcome to this course on Illumination Engineering and Electric Utility Services. Continuing with the previous lesson, we go on to the next lesson, lesson number 4 on Eye and Vision part 2. The instructional objectives for this lesson are: number 1, what is visual acuity? 2, list qualitative factors responsible for visual acuity. 3, state how the acuity varies with other parameters. 4, state minimum illumination requirement for good visibility, and define chromatic aberration. Recall that in the previous lecture we had a look at the general structure and function of eye, wherein we saw that eye has 3 important components, that is iris, lens and the retina, and all the light that gets into the eye is communicated to the brain through set of nerves located on the retina, and the most important point on the retina is the fovea, where the maximal sensitivity is there, and the 2 set of nerves that are responsible are cones and rods. Cones are responsible for dim light, in bright light, and they are responsible for formation of details and the formation of details and in bright light, whereas rods are responsible for the overall appearance, that is, orientation is taken care of by the rods. Now, we observe that today the tasks are predominantly involving eyes, that is, as already told, the most common task is reading and writing, which involves observing fine print and maybe over a longer duration. In fact, every sphere of our activity involves some form of writing and reading and is much longer than what it was in the prehistoric times. All this calls for increased illumination, and therefore, one observes that the finer the task is, more is the illumination requirement. We have seen how the focal ability of eye is adjustable, in the sense that unlike a camera lens, the human eye lens can change its shape. It flattens when there is dim light and becomes convex when there is bright light, accordingly adjusting the amount of light entering the eye, also sensitizing the appropriate set of nerves on the retina. See, the quality of light is also equally important. It is not just illumination alone, that is, if you have more light flux, we say that we can see more critical reading or writing, but it is not enough. It is the kind of light or quality of light is also important, as already told right in the beginning, that illumination not only helps in observing and acquiring information. Recall that information acquisition through eyes is the most important sense organ, and it plays not only on the physiology and psychology, the environment also is affected, and psychological requirements do play on emotions. The artificial illumination, whether aims at bringing it close to natural illumination and is affected by not only the type of source we use, type of environment we have, and the place where it is placed, that is, physical characteristics of the object being viewed or the room being illuminated. That is how physical characteristics of the room come into play. Where the physical characteristics could be in the form of the finish of walls, whether the light gets reflected or absorbed. All of us are aware, most of our residential rooms are with white roof, so that the most of the light impinging on the roof or the ceiling gets reflected and is available for tasks on the ground or on the table. That is how, and even in the walls, see most of the light is allowed to reflect and is. Now, on what factors does quality depend? Quality depends on the factors, namely glare. Glare, we said, is the intense light flux in the plane of observation. Let us say we are reading a board. If there is intense illumination on any portion of the board, then the discomfort felt by the observer is what we call glare. Diffusion, we all understand the light diffusion. In fact, the diffusion to some extent enables uniform spreading of light flux direction, naturally the way the light is oriented. Composition, it pertains to mixture of the light colors, whether the combination, like we talked about the physical environment, that is the ceiling color, wall color and the texture. So, the composition of the lights and how it is distributed, these are the things which talk about the quality of illumination. Quantity per se would be the light flux that is coming out of the lamp, and if efficacy is what we talk in terms of lumens per watt of energy that is consumed. And considering various aspects, the quality impact parameters, and through exhaustive study by researchers, it has been found that for equal visibility under varying conditions, the illumination has to be at least 100 foot candles or more. What are foot candles will become clear as we go along and study in the next lesson on the standardization and measurement quantification of light. Now, various factors that come into play in looking at the light quality are visual light quantity or quality, or ability of eye to respond to the light, or visual acuity. Discrimination, visual acuity we said is ability of our eyes to perceive things in the given situation depending on the external physical conditions, illumination available and the requirement of observation. Discrimination of brightness difference, that is, one should be able to distinguish between the two different objects, one may be bright, other could be not so bright. Speed of retinal impression, obviously we said the image perceived by the brain is a result of countless impressions obtained by the human eye. Therefore, every person has his own way of getting the impression. On an average, all of us have similar speeds, but it does have an importance in the way we perceive things. Obviously, the seeing is not essentially getting light into the eye, it is the response of the nervous system, double nervous systems on the retina and communicating to the brain, and therefore, nervous muscular tension does play a lot of role. We did mention in the earlier lecture that fatigue can really reduce the ability of distinguishing details, or alternatively it can call for increased illumination levels. As we said, there is always the requirements become contradictory and it is possible to achieve the end target by making a compromise in one or two of the factors that are involved. And we said adjusting ability or accommodation ability of the eye is essentially because of those muscles which tend to open or close the pupil or iris through which the light enters, and of the ability of the lens being flattened or being made convex with the help of ciliary muscles. Now, depending on how fast or how slow we do this process, accommodation and adjustment is called upon, the fatigue sets in the muscles. Therefore, fatigue of ocular muscles means eye muscles, and of course, just as any other activity of the human beings, heart rate plays a vital role and it is necessary for good illumination, I mean perception by the human eye. Normalcy of heart rate is important, and obviously we have a certain rate of reading. In fact, some of us read very fast, some of us read very slow, but there is an average rate of reading which we could call it as normal rate of reading, considering that is based on the font size or the font size of the text that is written and ability of average comprehension, considering that it's, and obviously you are expected at times to read faster. There should be a peak rate of reading. In fact, the well known information can be read faster, like you have abbreviated text sometimes. And how precise the task is. Say we are trying to solder some electronic circuit on a printed circuit board. The task has to be precision task, because we are going to solder components over a small area, which is calling for more microscopic precision involved. The other task which is involving precision is by the tailors when they try to thread the needle. That is a very tricky task, because through a small eye of the needle one has to thread it, and all this is assisted by taking a demonstration in a visual test. And sometimes some of us, because of maybe due to age, use or abuse, we do develop defects, and these defects normally which are corrected with the help of glasses are called refractory errors, and you can have to look into the visual acuity in defective vision, and all this has to be correlated with our experience in functioning in the normal daylight, because all our systems are trying to arrange artificial illumination system which is as close to the natural light as possible, and one can see that the illumination requirement vis-a-vis the visual parameters are logarithmically related. We will take up some of these and see how they work. Now, here is a graph which shows the visual acuity in the vertical axis and the illumination levels on the horizontal axis. It is marked as 1, 10, 100, 1000 foot candles. Now, here it is assumed that whatever visual acuity you have corresponding to the first vertical line is marked as 100%. It corresponds to 1 foot candle. If we standardize the visual acuity of an individual, of course, how was these things measured? These things were measured by considering normal adults of a large group measured over a long period of time, and the average is taken. If that be 100%, it is found that if we increase the illumination by 10-fold, logarithmic increase by 1 decade to 10 foot candles, the visual acuity increases by about 130%. And if we go further on to 100 foot candles, we find it goes to 170%. And it can be seen, it is observed, though not marked on this graph, further increase does not really enhance visual acuity very much, that is, it tends to saturate. So, anything between 1 to 10 per foot candles, if we set the certain acuity is 100% at 1 foot candle, it becomes 130% by going to 10 foot candles. So, if a particular situation, the 10-fold increase in the illumination did improve visual acuity, but 100 or 1000-fold increase would not really make that much of a difference. The next parameter is the contrast sensitivity. We said our eyes should be able to distinguish irrespective of the background. Now, we understand it is very easy if you had to read a white letter on a black board, but if you had to read a light orange color letter or a yellow colored letters on a white board, it would be very difficult. Contrast is not very clear. As you can see, the illumination requirements vis-a-vis contrast sensitivity, if I define the contrast sensitivity to be 100% corresponding to an illumination level of 1 foot candle, I find by an increasing the illumination level 10 times to 10 foot candles, that is a 1 decade increase, I find the contrast sensitivity of the eye increases to 80%, and by increasing to 100 foot candles, the sensitivity of contrast sensitivity becomes 450%. That means, even if the colors are close by, its ability to distinguish becomes more and more as we have higher illumination. These are some of the measurements that have been made to enable and understand the quality of light required based on the human eye performance. See, after all this particular talk, we are looking at how the human eye responds. The next important thing I said in trying to adjust to varying levels of illumination and varying levels of requirement for the observation, the muscles have to move, make certain movements whereby they change the lens shape or open or close the pupil. All this leads to some kind of a muscular tension. If I now, we know tension is nothing but is a kind of a pressure, it is measured in terms of a say of mercury. Similarly, or in terms of a pressure can be measured in terms of a kg force per unit area. So, to some arbitrary unit, if I find that the muscular tension corresponding to 1 foot candle is 639, I find by increasing the illumination to 10 foot candle, that is increased by 1 order or by 1 decade, I find it comes down from 639 to 549 by about 100 in about 600, that is 1/6. 1/6 would approximately mean 16% reduction. You further go down to go higher in illumination to 100 foot candle, you find it comes down by 200, that is about 1/3 reduction. So, it becomes 66% of what it was. So, what do we see? We saw in the previous one that visual acuity improves with the increased illumination, though it does not really improve much beyond 100 foot candle, and ability of distinguishing in near close contrast also improves. See, we found it has become 4.5 times when you go from 1 foot candle to 100 foot candle, and visual acuity has become 170%, and we find that the muscular tension has reduced by about 30% to initial value of 639 to final value of 439 at 100 foot candles. These are some of the things. That means there is a certain advantage in terms of the functioning of the eye by having increased illumination. And one other thing which you find, if there is requirement of reading or doing exacting tasks and adjusting the eyes, we find that there is a certain rate of blinking that is necessary because of the varying levels of illumination or varying levels of requirement. And this frequency of blinking after reading for an hour is observed, and if it is standardized at some level as 100% for illumination equal to 1 foot candle, you find that when the illumination increases to 10 foot candles or 100 foot candles, it reduces. As can be seen, it is around 77% for 10 foot candles and 65% for 100 foot candles. That means there has been a decrease of 30%, 35% in blinking rate because of increased illumination. All this helps. And however, the other important issue, remember that the eye is able to capture fine details by converging the incoming light rays from the object on the central point of the retina, which we call fovea, which is located where the nerve cells responsible for micro details are cones, and in doing this one has to basically does by the help of ciliary muscles which make the lens convex in nature, and this ability of converging the incoming light. So, how does it do? It basically closes its pupil, makes it closer, and then thereby light gets converged, the lens becomes convex and you get the light converged onto the focal point. Now, this ability convergence is less if the illumination is low, as can be seen. The decrease in convergence is high at 1 foot candle, whereas it is much lower at 100 foot candle. The figures given here are 23% for 1 foot candle and 7% for 100 foot candle. So, we see, if you can recall once again, we see the visual acuity improves with the increase in illumination, the contrast sensitivity improves, and the increased illumination is able to reduce the muscular tension, and also the blinking rate reduces, and obviously the error in convergence. What does this mean? Decrease in convergence would amount to meaning that if you continue reading for a long time in reduced illumination, eyes start paining, that is what is a nervous muscular tension, and you start reading erroneously. You do not read what is there, probably you read what is there in your mind, you do not read what exactly is written. That is the error in convergence. These are some of the issues which come up. So, we can look at some of the recommended illumination levels based on the experience, keeping these visual conditions or factors responsible for visual acuity. You see the recommended foot candles for various operations. Now, this is a very critical task which has been listed here. Observe, we are looking at observing a black thread on a black cloth, which means contrast sensitivity has to be very high, and that is why we did find that when compared to what was the contrast sensitivity at 1 foot candle, it becomes 450% at 100 foot candle. But these two being very close in wavelength, you will need much higher. The newspaper, the stock equations which are put in bold print, you need about 100 foot candles. Stock equations are normally written in very small print, you must have seen that, it is very difficult, and some of the elderly people are forced to use glasses. Typing on a dark blue paper, typing is usually done in using a black or blue ink, again it calls for about 80 foot. Telephone directory, we know these are yellow pages, they are thin pages, and large number of information is tried to be put in a single thing. The only advantage here is contrast is large, it is black and white, though they are yellow pages. The newspaper text, the white background with reasonably big text, about 40 foot candles. If the printing is good, well shaped letters, you find for a 6 point you need about 10 foot candles, and you go to 8 point you get 8 foot candles. and if the paper is very good, pristine white background, 12.5 foot candles. See here you find that there is a statement mentioned along with this print corresponding to 6 point, 8 point, 10 point and 12 point, which says contrast is very large. That means you really have a very dark, a very large contrast, that is you are looking at a white background with black letters. So, the other criteria which are necessary for the functioning of the eye from the point of view of observation, apart from increased illumination levels. What we are trying to say is, yes, we did find the eye functions better with the increased illumination, but that alone will not do. The factors that are responsible are visual acuity, which we have seen how it varies, visual efficiency, that is depending on how efficiently one is able to observe the required object, speed, ability of observing the required time, health depending on use, abuse or age. Now, here we have been talking about acuity quite a bit, but still we have not really defined acuity. So, it is better that we formalize what we understand by acuity. Acuity is the ability of the eyes to distinguish the details depending on the brightness of the object and keeping in mind the contrast details and the nature of the light that enters the eye. Now, black object on a white background, you can see the how the visual acuity varies with your background brightness. Background brightness is given in terms of the what you call foot lamberts. As can be seen, it is going from 0.01 to about 1000 foot lamberts. Recall, one lambert is 1 over pi candles per meter square. Candles, I said the standard of light is taken as a wax candle, and therefore, you can say the light flux to be proportional to a candle, and amount of light incident on 1 unit area in meter square is considered in terms of a lambert. And supposing the area as against meters is taken in FPS system, it becomes foot lamberts. What do we observe? We observe that the maximum acuity of 2.6 is around above 1000 foot lamberts, and see 95% acuity, 95% of the maxima is coming around 1300 foot lamberts, whereas 90% acuity is possible with 150 foot lamberts. So, what does it mean? So, the requirement to get good acuity does increase with increased illumination, but beyond some point it tends to saturate. In fact, this particular curve also talks about the critical angle at the eye with respect to your the what we call the background brightness. Further, acuity also depends on the surrounding brightness. This is how the what you call your contrast comes into picture. Again, here acuity is drawn along the vertical axis, and we find that the maxima in this curve is seen to be around 1.2 to 1.4 foot lambert. Okay. What do we find is the background brightness. Now, this particular curve corresponds to the test object brightness of 12.6 foot lamberts. What does it say? It says that approximately 1/10 surrounding brightness enables good acuity of observation. This is a very important thing. What it says is the brightness of object vis-a-vis the surroundings. How should it be related? If you see the statement given below, B surrounding should not be much larger than the test object. At the same time, it should not be very smaller than test object. And what we find, the peak in this particular case has been between 1.2 to 1.4 foot lamberts of the background brightness. Here the object itself is 12.6 foot lamberts. That is the important issue. Now, this particular thing looked at other way around. In fact, the previous diagram we had a look of variation of the surrounding brightness for a fixed test object brightness and the variation in acuity. Now, let us take the brightness of the object vis-a-vis visual acuity and how it is varying. We find there are three curves here. The first one, the bottommost, corresponds to B sub s equal to 0, meaning it is a dark surrounding, brightness of the surrounding is negligible, and you do find the acuity is around 1.8, but it is still not high. That corresponds to somewhere close to 100 foot lamberts of the test object. On the other hand, we do find when the surrounding brightness is increased to 0.011 foot lamberts, the acuity reaches a peak value of 2 at about 100 foot lamberts of the test object. But should we make the surrounding brightness equal to the test object, the visual acuity keeps on increasing, but that may not be all the time possible. Then the last thing that needs to be done, looked at, is how the ability of observing or reading goes with the brightness. If you see, the brightness is marked along the x axis. The two examples have been taken. Curve A or the line A corresponds to a situation where 80% white background and B is 23% gray background. What do we observe? We observe the percentage change in speed when the background is white, considering a standard English type, is not much with increase in brightness. On the other hand, in a gray background, we find there is a rapid increase in change in the speed. We have around 100. If it is 100% at 10 foot lamberts, it comes to close to 160 at 20 foot lamberts. Lastly, one has to look at the thing that age has its own impact on the visual acuity. With increasing age, vision reduces. This because of decrease in pupil size, which is mainly due to the elasticity of the pupil being decreased, or the muscular elasticity reduces, and as a result even the optic lens becomes less flexible, and all this results in difficulty of adjustment of the focal length, and hence one needs higher illumination as age increases. In fact, we find the curve given for brightness requirement at any age, considering a 20-year-old as the reference, we find that as you go higher and higher, it is much higher requirement, as can be seen from this curve. At the age of 60, typically when one takes retirement from the active life, it is 2 times that at 20 years. So, this is the way age affects. Now, this apart, our eyes are comfortable and perform best with a monochromatic light, and they are able to form distinct images on retina and are able to distinguish details well. However, the monochromatic lights essentially is obtained from the physical process of electroluminescences, which is used in gas sources. The lamps are mercury or sodium. In fact, fluorescent lamps are nothing but low pressure mercury vapor lamps. And one must observe that it is the three primary colors red, green, blue, which mixed in a particular way can give rise to all the necessary colors. In fact, this is, but as the eye has the ability to have good acuity for a monochromatic light, the combination tends to reduce acuity. This can be understood by this diagram, which shows, supposing that eye is focused for yellow. You remember that the sensitivity of the human eye is maximum around 550 nanometers, which is in yellow green color. Now, we find that if it is focused for yellow, the red having a larger wavelength would go behind, and blue having a lower wavelength would be ahead of the retina, and this would give rise to error in observation, which we call chromatic aberration. And there is a lag in sensing these colors, and again all the time one has to remember that it is the time of observation matters a lot. Therefore, depending on the presentation and cessation of stimulus, the colored objects are felt, and all this together is what we call the chromatic aberration. And the sensation wise, the eyes are able to sense blue the fastest because of the smaller wavelength, and green the slowest. Simultaneous contrast maximum when the colors are away in the spectrum. If they are close by, it is difficult. Now, once again let us have a look at how these color temperatures are located and where our eye is. So, we saw this, how the natural light and the artificial sources are put along with the color temperature scale. As you can see, the blue northwest sky is around 20,000 degree Kelvin, corresponding to a fluorescent lamp with blue glass filters. Now, if you see on the right hand side, daylight fluorescent lamp is around 6,000 degree Kelvin. Similarly, you have the noon time sun around 5,300 degree Kelvin, and you have the high pressure white fluorescent lamp marked around 4,500 degree Kelvin, and the candle flame comes at the bottommost with 2000 degree Kelvin. So, with this, the once again before we close, we look at the eye. Eye has three major parts similar to a camera. One is iris, which allows the light to go in or go out, and two, the lens similar to the lens in a camera, which can change its shape. It flattens for dim light and becomes convex for bright light. And three is the retina, where the image is formed, which is sensed or communicated to the brain through a set of double nerves, which are called cones and rods. A lot of cones are present at the fovea, which is the point of maximum sensitivity. So, we saw that the illumination has role in affecting our physiology as well as psychology, and therefore, it is not enough if we look at the quantity of light, but quality of light is also important. The quality of light is affected by the glare present. Glare, we said by definition, is intense light present in the plane of observation, the way it is diffused and how the illumination is directed or focused, together with its distribution and composition. Minimum lighting required for good visibility is 100-foot candle or more, considering all aspects of the human eye functioning. Now, we also saw that for good visibility, brightness of surrounding should be greater than 0.01 time foot Lamberts, or it should be less than that of the test object. Now, here we saw that there should not be a large difference in brightness between the surrounding and the test object. Ideally, 1/10 of the test object should be the surrounding brightness for getting good visibility. Apart from illumination, the vision or the visibility of human eye is talked in terms of visual acuity, visual efficacy, speed and health. Health basically talks about the errors that are possible and fatigue that is set in. Acuity is what? Acuity is the ability to distinguish details depending on the brightness of the object, characteristics of the light entering the eye and contrast maintained. Now, one important thing to be kept in mind, that with age visual acuity reduces. This is because of the decrease in size of the pupil and elasticity of the pupil. This is essentially because of the reduction in elasticity of the muscles, and ability to flex the optic lens reduces. This leads to higher illumination requirement. We saw, taking reference to a 20-year-old at the age of 60, for the same conditions one needs 2 times the illumination requirement. Monochromatic light is what monochromatically the eye functions or acuity is at its peak and forms distinct images on retina, and combination of colors does reduce the acuity. We saw how when a eye is focused for a yellow light, if you find a red signal or a blue signal, how the image is formed behind or ahead of the focal point, and thereby there is an error. The error due to this is what we call chromatic aberration, and there is a certain time lag for sensing the colors, and this depends on the way it is presented, the way the stimulus is removed, and it is different for different colors. Some of the questions: why is quantity as well as quality of illumination important? What should be the minimum brightness of the surrounding? What are the 3 primary colors? How does aging lead to loss of vision? What is chromatic aberration? Why does it occur? Coming back to some of the questions, answers to the questions in the previous lecture: which is the most acute spot in the human eye? The fovea, as accounts for the fine details of the image formed, is the most important or acute spot. What are the 2 types of vision? The 2 types of vision human eye has are photopic and scotopic, that is pertaining to rods and cones. Distinguish between rod cells and cone cells. Rod cells, scotopic vision, function in dim light when brightness is less than 0.01 foot Lamberts. No color discrimination ability exists during this vision and lack sharp details. One observes in form of a silhouettes and greyish appearance. Cone cells, on the other hand, have photopic vision. They cease to function in dim light. Color discrimination and fine details are their ability. How does eye communicate with the brain? Through a set of optic nerves, the double nerve system, that is what we call rods and cones. What is the diameter of the pupil? Diameter of the pupil is around 1.2 to 2 mm. How does eye function under varying illumination? By change in pupil size together with change in retinal nervous system. It must be mentioned that here the ciliary muscles are the ones which help in changing the pupil size. And why is red color used for the stop signal? The eye can easily sense red color from a distance due to its large wavelength, so that one get enough time to react and stop. Thank you.